Imagine your younger sister has asked you to show an aeroplane or a train or a car. These are the actual real object with length and height, so it is easy to show. Suddenly, she is asking to show how much do you love it? Is it possible to show? No, because love is abstract quality which can only be imagined. Similarly, numbers are abstractions of the mind that we use to help us calculate the real world. Real numbers only describe a perfect simplified world. If we deal with negative numbers, a new concept called imaginary number, I, was introduced to find the roots of complicating factors found in the real world. This is actually called complex number. Complex numbers are useful in representing a phenomenon that has two parts varying at the same time. For example, AC current which changes its magnitude periodically. Let us discuss it in detail about this complex number. What is actually complex number? Complex number is a sum of real and imaginary numbers which are represented in the form a plus ib, where a is the real part and ib represents the imaginary part. For example, 2 plus 5i. Now, how does this I came and who invented this? We have seen linear equation in 1 and 2 variables and quadratic equations in 1 variable. There are no real numbers for the solution of the equation x square plus 1 is equal to 0. Again, x square is equal to minus 1. We get x is equal to plus or minus root of minus 1. That is, x is equal to plus or minus I. So here, I is equal to root of minus 1 and the number is defined to have the following property. That is, I square is equal to minus 1 and this Greek letter I is called iota. The famous mathematician Leonhard Euler proposed this new number called I such that I square is equal to minus 1. Then how to calculate the powers of I? Let's see it. Integral power of iota. What is I? I is equal to root of minus 1. I square is equal to minus 1. Now, how can you write I cube? I cube can be written as I square into I. That is, I cube is equal to minus 1 into I, which is equal to minus I. Now, let me ask you, how can you find I raised to 4? Which can be written as I square into I square. What is I square? Minus 1. So, we get minus 1 into minus 1, which is equal to 1, and so on. So, when we are solving the problems related to powers, we can separate it in the powers of 4 because I raised to 4 is equal to 1, which makes our calculation more simpler. Now, let's see some examples. Simplify I raised to 70. How will you solve? Let's see the solution. Now, this I raised to 17 can be written as I raised to 16 plus 1. 17 splitting into 16 plus 1. Now, it is further written in the power of 4 to make our calculation simpler. So, I raised to 16 can be written as I raised to 4 the whole raised to 4 into I. What is I raised to 4? Which is 1. So, we get I raised to 4 into I, that is 1 into I. We get it as I. Now, let us concentrate on the algebra of complex numbers. First, let's discuss about sum of two complex numbers. Assume two complex numbers, set 1 is equal to a plus bi, set 2 is equal to c plus di. In order to add these two complex numbers, we have to add the real parts together and imaginary parts together. So, what we get? Z1 plus Z2 is equal to a plus c plus I into b plus d. That means taking the real part, then taking here imaginary parts together. Alright, let's see one example. Add two complex numbers. Set 1 is equal to 2 plus 4i. Set 2 is equal to 5 plus 3i. Let's see the solution. So, in order to find the sum of these two complex numbers, what we have to do? We have to take the sum of real parts. We get 2 plus 5, that is 7. Now, the sum of imaginary part, again we get it as 4i plus 3i, that is 7i. So, our Z1 plus Z2 will be equal to 7 plus 7i. Now, let us see some properties of addition. The first property, that is closure property. Adding two complex numbers results in another complex number. The second property, commutative property, it states that the two complex numbers Z1, Z2 such that Z1 plus Z2 will be equal to Z2 plus Z1. Third property, associative property, for any three complex numbers Z1, Z2, Z3, Z1 plus Z2 plus Z3 will be equal to Z1 plus Z2 plus Z3. Now, the additive identity of the complex number is always 0. The additive inverse of the complex number Z is minus Z. Now, let's see how the difference of two complex numbers are performed. Assume the two complex numbers Z1 and Z2, where Z1 is equal to A plus BI and Z2 is equal to C plus DI. In order to subtract the two complex numbers, we subtract the real parts separately and the imaginary parts differently. So, Z1 minus Z2 is equal to A plus BI minus C plus DI, which is equal to A minus C plus I into B minus D. Taking the real parts, taking the imaginary parts separately. Now, let's see one example. Subtract the two complex numbers. Z1 is equal to 3 plus 2i. Z2 is equal to 1 plus 3i. Let's see how the difference is carried out. Solution. Z1 minus Z2 is equal to 3 plus 2i minus 1 plus 3i. What will we get? Taking the real parts. So, we get 3 minus 1 plus I into taking the imaginary part, that is 2 minus 3. So, we get it as 2 minus I. Now, next we will see the product of two complex numbers. In order to understand the product of two complex numbers, we have to assume the complex number Z1 is equal to A plus BI, Z2 is equal to C plus DI. Each part of the first complex number get multiplied by each part of the second complex number. That is A plus BI into C plus DI. Now, taking inside, we get it as AC plus ADI plus BCI plus BDI square. Now, what is I square? It is minus 1. So, we get Z1, Z2 is equal to AC plus AD into I plus BCI minus B into D. Now, again rearranging, we get the final result as AC minus BD plus I into AD plus BC. Now, we will see some properties related to the multiplication of a complex number. The first property, that is closure property. It states that the product of two complex number is always a complex number. Second property, commutative law. For any two complex numbers Z1 and Z2, Z1 into Z2 will always be equal to Z2 into Z1. So, the third property, associative property, for any three complex numbers Z1, Z2, Z3, Z1 into Z2 into Z3 will be equal to Z1 into Z2, Z3. Now, what will be the multiplicative identity? The multiplicative identity of a complex number is always 1. Now, what about the multiplicative inverse? The existence of multiplicative inverse is 1 by Z. Now, last one, distributive property. It's a very important property. For any three complex numbers Z1, Z2, Z3, Z1 plus Z2 into Z3 will be equal to Z1, Z3 plus Z2, Z3. Alright. Now, let's see the examples related to product of two complex numbers. We have Z1 is equal to 1 plus I, Z2 is equal to 3 plus I. Now, our aim is to multiply these two complex numbers. So, we get Z1 into Z2 is equal to 1 plus I into 3 plus I. Now, taking inside, we get 3 plus I plus 3I plus I square. Again, substituting I square is equal to minus 1, we get 3 plus I plus 3I minus 1. Now, rearranging, we get the final result as 2 plus 4i. Alright. Next comes to the last set, that is division of complex number. To understand the division of two complex number, again we have to consider two complex number. We have Z1 is equal to a plus bi and Z2 is equal to c plus di. Now let's divide them. That is Z1 by Z2 equal to a plus bi plus c plus di, where at least one of c and d is non-zero. Now next what we have to do, we have to rationalize it. That means that is a plus bi by c plus di is multiplied with c minus id in the numerator and the denominator. So we get it as ac plus bd by c square plus d square. That will be the real part. Now the imaginary part will be bc minus ad by c square plus d square. Next we will see the square root of a negative real number. The square root of the negative real number is called imaginary number. For example, root of -3, root of -5. Let us first discuss about the positive real numbers. Consider equation x square minus 4 is equal to 0. So taking 4 other side, we get x square is equal to 4. Again, what will be x? X is equal to plus or minus 2. So the equation gets two solutions, that is either plus 2 or minus 2. Similarly, let's check for the negative real number. We have the equation x square plus 1 is equal to 0. Taking the other side, we get x square is equal to minus 1. Now what will be x? X is equal to plus or minus root of minus 1. And what is actually root of minus 1? That is I. So we get x is equal to plus or minus I. That means it has two solutions, plus I and minus I. So we have already discussed that root of AB will be equal to root A into root B. Now this condition is true for all positive real number A and B. That means both A should be greater than 0 and B also should be greater than 0. Even when A is positive and B is negative, this condition holds true, and vice versa. That is A less than 0 and B greater than 0. But it does not hold for negative real numbers of A and B. That means when the case is A less than 0 and B less than 0, this condition does not hold true. Now let's prove an identity. Z1 plus Z2 the whole square is equal to Z1 square plus Z2 square plus 2 into Z1 Z2. Now first, according to the distributive law, we can write it as Z1 plus Z2 the whole square is equal to Z1 plus Z2 into Z1 plus Z2. Again, taking it inside, we get it as Z1 plus Z2 into Z1 plus Z1 plus Z2 into Z2. Now, we can write it as Z1 square plus Z2 Z1 plus Z1 Z2 plus Z2 square. And we know that these two quantity, according to the commutative law, they are equal. So we can write it as Z1 square plus 2 into Z1 Z2 plus Z2 square. So hence we have proved this identity. Now let's look at some more identities. First one, Z1 minus Z2 the whole square. So earlier it was Z1 plus Z2 the whole square. Now it is Z1 minus Z2 the whole square. So the equation will be Z1 square plus Z2 square minus 2 Z1 Z2. So the same procedure we have to follow here also. Now what will be Z1 plus Z2 the whole cube? This will be of the same form, A plus B the whole cube. So here similarly we get Z1 cube plus Z2 cube plus 3 Z1 square Z2 plus 3 Z1 Z2 square. Now what will be? Now what will be Z1 minus Z2 the whole cube? It will be Z1 cube minus Z2 cube minus 3 Z1 square Z2 plus 3 Z1 Z2 square. Now again one more identity, that is Z1 square minus Z2 square. This is of the form A square minus B square. So we get it as Z1 plus Z2 into Z1 minus Z2. So we have seen the multiplicative inverse of a complex number is 1 by Z. Then what would be the conjugate of the complex number? which will be taught in the upcoming concept video. Until then, enrich your knowledge through learning. Now, let's summarize what we have learned.
Manorama Horizon. Learning made simple.